Hey chemistry, so today we're going to do a demo to demonstrate density and how it affects different liquids. This is going to be a kitchen chemistry demo. What that means is that I'm working out of my kitchen because it's a pandemic and I'm not in the lab right now. The chemicals that I'm going to be using are common household chemicals that are considered like everyday use. So these are not strong acids, these aren't strong bases. What we've got is vegetable oil, which y'all can eat. Y'all use it in cooking all the time. We have a glass of room temperature tap water, and we've got some Dawn dish soap. So these are the only three things I'm going to be working with today. Again, since I am doing this at my house and it's called kitchen chemistry, I won't be using any what we consider toxic or hazardous chemicals. Those are reserved for the lab where we've got the proper safety equipment and ventilation to deal with them. Out of these three, the only one that you can consider to be mildly hazardous is the Dawn dish soap. I expect y'all as 10th graders to be big kids, not to drink this, don't put it in your eyes. Make sure that the counter that you're working on doesn't have food or things that you're eating or drinking on it so that nothing will get contaminated, and you're good to go. So what I'm going to do is I'm going to take the Dawn dish soap and I'm just going to dump it into the cup like this. And you'll need a lot. Please do not use all your mother's dish soap. If you're going to try this at home, make sure she's aware of it and leave some left over. As a mom, that would make me very mad. All right, so I've got my Dawn dish soap in the bottom of the cup, and on top of it, I'm going to pour my vegetable oil. I want you to think about the differences between Dawn dish soap and vegetable oil and see if you can predict what's going to happen when I pour the vegetable oil on top of the dish soap. To do this, I am going to be using a spoon. Just any old kitchen spoon will work. This is a technique that we use both in chemistry and in mixing drinks. If you've ever been to Starbucks and you've seen those multicolored drinks, they get that way because they use a spoon to offset the impact of the liquid. The spoon basically causes the liquid to pour out at different angles so it doesn't all go into the bottom of the cup at once and blend with the liquid underneath. So I'm going to hold the spoon upside down and put it inside the cup. And I'm going to pour the vegetable oil onto the back of the spoon. Slowly to try not to disturb that soap liquid underneath. Okay. If I was smart, I would have gotten a paper towel. Since this is vegetable oil, I don't mind it being on my counter. Please make sure if you do this demo at home that you clean the counters afterwards with soap and water so they aren't oily or soapy. All right, so you can see I've got two different layers. I have the dish soap in the bottom and the vegetable oil in top. And you can see the line between them. It's really crisp, really clear. They almost look like two different solids. Now, if I stir these, they will mix. Don't stir them. But I want you to think about what could be causing those to separate right now. Why does one sink and the other float? We're going to be adding one more liquid. This is our water. Please make sure your water is room temperature or cool. You don't want it too cold and you don't want it too hot. And I want you to kind of try to predict where is the water going to go. Again, I'm going to take my spoon to minimize the impact. I'm going to hold it upside down. I'm going to carefully pour the water over the top. I have never had success with pouring water out of the cup without it spilling a little bit. Go ahead and see if I've got a different container. All right, we're going to use a measuring cup. All right, so I've got a measuring cup instead. It's got my exact same water. I'm hoping that this minimizes any spill. Again, if we do have a spill, it's just tap water, cleaning up with a paper towel. Right, so I'm going to pour the water over the back of the spoon. We've still got spillage. This is what your paper towels are for, or your washcloths. I miss my lab equipment. Okay. All right, guys, so the oil is going to be yellow, the water is going to be white or clear, and the soap is going to be blue. Take a close look at the 3 different layers, where each one is. So we've got the blue soap on the bottom, we've got the clear water that went to the middle, and we've got the yellow oil on the top. Why did the water go to the middle and not to the top or the bottom? Well, this experiment has to do with density and how the density of different liquids affects whether they float or whether they sink. So on this piece of paper, we've got our definition, which is density for the day. Density is a physical property of substances. That means it's just a characteristic of what the substance is. The formula for density is written here, mass divided by volume. When I calculate the density for each of these substances, I notice something interesting. The oil has a density of 0.92 grams per mil, water has a density of 1 gram per mil, and the soap has a density of 1.06 grams per mil. So you notice that the soap is the most dense, the oil is the least dense, and the water is right in the middle. The densities of these objects causes or influences whether they will go to the top or go to the bottom. Things that are more dense will sink, and things that are less dense will float. So the oil is the least dense, it's going to be on top. Water has the middle density, so it's going to be in the middle. And the soap has the greatest density, so it's going to sink to the bottom. And this is why you get this really cool layered effect. If you try to repeat this experiment and you did the soap first, the water second, and the oil third, you'd get the same pattern. If you did it a different way and you did the oil first, the water second, and the soap third, the soap would still sink to the bottom. You'd get the exact same pattern because they layered based on these densities in this order. So again, try it at home if you don't believe me. Any type of oil will work. If you've got peanut oil, vegetable oil, olive oil, regular tap water, and any type of dish soap should sink to the bottom. So hope you enjoyed that demonstration. And if you're going to do this at home, do not drink it. Absolutely do not drink it. You wouldn't drink soap. Don't drink this. Make sure you have your parents' permission. And please clean up when you're done. Just rinse the glass thoroughly. Make sure there's no soap or oil left into it. Use paper towels to clean the counter. If you got any oil on the counter, you might want to clean it up with some soap too. All right, guys. Thanks for watching. Keep learning chemistry.